Hello friends. So what I have here in this session is a flat file compare ETL driven tool for helping us compare large flat files. Now while we are trying to migrate a legacy DTS, which was the 2000 version of ETL, Microsoft's ETL, to SQL Server to 2012 SSIS or 2008 version of SSIS, it is important that the end product, that is the flat file being generated by these SSIS packages, is in total sync with the DTS version, which means that various downstream applications or users who are actually consuming these flat files as their input should not be impacted. So to make sure that the content and the delimiters are in complete sync with each other and the migrated version is in line with the legacy ETL versions, it is important that a proper QA has been performed on these flat files. So currently the industry in the industry we have certain tools like Beyond Compare which help us compare flat files. Yet again, when the flat file size grows beyond 2 GBs, it is the Beyond Compare is helpless and is not able to compare the flat files properly. So and more so, there is a manual comparison that needs to be undertaken in Beyond Compare to check what are the records, or what are the data which are a mismatch in these source and the target files. So to automate the process and also to get the results, I have a tool in place. I have created a tool in place to do so. Let's try to take a look what we have in this session with regard to the tool. So it is the good news is, from further all my blogs would be on 2012 version of SQL Server, as well as we'll be using SQL Server Data Tools SSIS version of 2012. So I have created a SSIS package on uh, which is a ETL driven tool for data compare. Now to start with, what I have in this SSIS package is we have two connection managers which are declared. But before that, let's try to take a look. Let's try to run the tool and see what this tool help us do. So what I have is a source and the target folder, and each of them contains two flat files. Now both the flat files have carriage line feed as the row delimiter, and it could be a comma for the column delimiter, and it could be a different pipe for a column delimiter. But the carriage line feed is something which is used as the uh, record delimiter across for all the files that we have that we are using. So that is a scenario. Now let's try to test it. When we run the SSIS package, we give couple of input variables. This SSIS package takes the source directory as an input parameter. It takes the destination target directory as an input parameter. It takes a value of which could be said as a unique value, which can help us query out the results. So we can call it a tested feed ID or whatever, and then then it takes the server on which you want to test. So the important thing to note is you should have the admin access on both the SSIS as well as the server. So sysadmin access is something required to be able to run this tool on the server that you are trying to compare. And then there is a value is create db, which is set to 1. We'll get to know each of these. So these are the input parameters that this package uses. Now let's try to run this package first and see what it does for us. Right, the package is run and the comparison is done. Now if we go and query our dev database, first important thing is there is a new database being created that is called compare database, and then our anchor database, which is a dev database on which we have a compare log table, which will actually give us the results, has populated the results for both the files comparison. So what we see here is the product file products has passed the results, and the file sales is not passed because there is one record which is a mismatch, and because of which it has failed. Now the testing criteria for this is we are if you see the compare database, we for each of the files from the source the file name underscore src will be created, and for each of the target files in the target directory, the respective file name underscore trgt extension will be created, and each of the file contents will be dumped into these tables. And upon this dump, it will the test result, the pass and the fail criteria for the test result is based upon the target count, so which is nothing but if you see the, the source count of this, it gives you 516, and the target count for this is also 516, and the accept count for each of these is sorry, we have to do a star, right, is a 1. So the criteria, the evaluation criteria is the target count minus source count should be 0 and the accept count should be 0, and only upon both of these conditions being affirmative we go with we populate the test result as pass, otherwise we populate it as fail. So we are getting the source and the target count, subtracting them and the value, and then the accept count. So if in the event that both these values are 0, we put it a pass, or we say it's failed. Now as we can see, there was one record which was a mismatch in the accept count, although the count of the number of records in both these files are same, yet there is one record which is a mismatch, so it has failed. So that is the tool for you. Now let's try to take a look at the detail what we have for in this tool. We have created two connection managers, and each of these connection managers are expression overridden. So the first connection manager is called data load master. So it has the server name which is overridden by a variable. The next is the data load server. It has the database name and the server name being overridden by the server, by the variables. Now let's try to take a look at the variables. In the variables we have isCreateDB, which will accept a value of 0 and 1. Then there is a compare var_db, which is the name of the database that you want to dump, which will act as a dump for the data from the files. Then we have the source and the target directories, and we have the server name and the tested feed ID, which is a unique identifier for your test that you have conducted. Apart from that, we can see that there are two system object variables and two basic string type variables. We'll get to know each of them as we try to explore the SSIS package. So first and foremost, we try to configure xp_command shell for your server on which we are trying to run against the data load master connection. Next, what we do is we try to create a database that is a compare database in the when the flag for isCreateDB is set to 1. So in the event that isCreateDB value is set to 1, it will drop the compare database and recreate that. And when it is 0, it would simply not do anything. That's all. So next, what we do is we try to build the metadata. So here what we see is we are using the connection data load server, and we are trying to create a table that is the hash table, and both these hash tables will be used for our processing. Now so these are the two tables. I'll explain each of their importance. So for now, let me try to run this script. So I've run that. So this is accepting no parameters. So next is in the next task we are accepting two variables, that is the directory source and the server. So source directory and the server. So here let's copy the T-SQL and I'm pasting it here. So what we can see is it is accepting the source directory here, and let me put this, and then it is also using the server name. so as a input parameter. So that's all the two parameters that are required. Now let me run this. So what this code does is, if we select, what we see is in the hash table we have actually populated the directory values, these versions, the file names, and then we have created a BCP command and a create drop and create table command. So for the source directory, so it will. So let's take a look at the uh, BCP command and also the drop and create table command. So for each of the files, if you see, what it does is, for each of the file it will append the underscore src to the file name, and it will drop the table and then recreate that. So this is the command. That's all for dropping and recreating. So with a single attribute, that is data and varchar max, which means we have the constraint of comparing only 8,000 characters of 8,000 characters of a record for that particular file. So that's the only constraint this tool has. So we do this. Let's try to take a look at the BCP command that has been prepared. It is trying to BCP the file, BCP in the file, or load the file into the compare database for the particular table from your file, from the directory that you have actually started a comparison, and this will be loaded on the server. This is again a dynamic value, and the delimiter that we'll be using is a it's an ANSI value. So what it is, like, the column delimiter that we have defined here is something which should not be present in any of the files. Say the column delimiter in your file is being used, is somewhere it is a comma, somewhere it is a pipe, or somewhere it is a tab. Accepted. Any of these values, you should, when you feed the value here, just remember that the column delimiter value, you can put anything apart from the column delimiter and a carriage line feed. So I have selected this value because my column delimiter will never have a value of this ASCII code. So which means what I'm trying to do is, it will load everything in one record. You'll treat each line as one record for the file, which means until and unless it encounters a carriage line feed, because the carriage line feed is a delimiter for the record or the row, so it will treat everything as one particular record. This will treat this as one record, it will treat as this as one record, until it will load this into the data column of the table. So if you see this, what I am trying to do is, each of these tables, if you see, has only one column, and that is data of n varchar max. So each of these columns will be loaded. If you take a look, will be loaded the data from each of the lines. So carriage line feed being the carriage line feed being the record or the row delimiter, it will load everything, because it will never find the column delimiter value. So it will not delimit. This is the column delimiter value, so it will not delimit at all. So that's all. This is a BCP command. Now next, what we do here is, we try to create the anchor table if it does not exist. So the anchor table is the compare log or the result table, which I have created in the dev database. You can select any database apart from the compare database, and you can actually create this table if it doesn't exist. So we'll take a look. We have already seen we've already seen what this table looks like. So it actually populates the file name, the source, the target, the accept count, the test result, the user who has executed, the run date, and the tested unique number, tested feed ID, or the unique number. Apart from that, I have also declared a primary key identity value. So moving ahead, once this is done, we do the same thing for the target. So we get the target directory and the server, and the code is similar. We simply load the value. here again, if you see, let's try to feed the directory, target directory value. This is the target directory. So let me feed this. This is the target directory, and again the server name is 12. That's all that we do. Now let's run this again, and if we take a look at the data, what we see is we have the target versions also loaded on the hash table. So again, it is actually creating the BCP commands for the target versions also, and also the table command, so for the target versions. So this is done. Now the target and the commands have been created. Now we start to process. The first process task is trying to create the tables first on the database. So if we see, we get the from the hash table we get the table create command. Now the important thing I would like to mention here is on this connection, since this connection is being used again and again, we have to, and we are using a hash table, we have to retain the same connection property to true, because we are using a hash table. Now the reason that we are using a hash table is we do not want since this tool can be used by multiple users, and we do not want a physical table, we want a temporary table, so that each of the sessions for each of the users have a dedicated hash table during the processing, which means each of the users will have their own versions of data compare metadata based upon their source and target directories, and their sessions will be used. Now if to be able to use a hash table in SSIS, we have to set the connection property to true, so that the connection is retained all across from tasks to task, because the hash table is used from task to task again and again. As you can see, we are using the hash table, we are populating the hash table in one task and using it in a different one. So we are trying to get the table create command, and with the full result set, we are mapping this result set to a system object type variable that we had declared var create table string. As you can see here, var create table string and the BCP string are of system object type. So we map the complete result set onto this, and then we use a for each container where we collect this value and then map it to our var exec SQL, which is a basic string type variable, and then we are simply trying to run. We accept this parameter as an input in an simple execute task, and run this in our query analyzer. That's all that we do with the help of sp_execute SQL. We are simply running this. That's all. In the next command, in the next sequence, what we see here is we are using we are getting the BCP value similarly, BCP command similarly, and we map this result to a var BCP string, and then with the help of the for each, we are collecting the value, mapping it to var exec BCP, which is a simple basic string type variable, and then running that with the help of sp_command shell. That is why we had actually configured this value initially at the start of our package. So this is, again, we are using a parameter and then running this. Now once this is done, the last step is to log the result. So this is the code for logging the result, if you can see. Now what it does here is, let's try to take a look. Once the tables are loaded, we simply iterate, we simply get the counts. Here what we do is we get the username and the tested feed ID as input. Once we get these are simply inputs. So username is a system username variable, and the tested feed ID is a unique number for that particular test. Once we get that, we iterate across the data compare metadata table for each of the files. This is the code to get the value. I mean, this would give you the two files. That's all, and we are comparing, and then we append the source and the target and get the count. The first step is to get the count of the source, the second step is to get the count of the target table, and then the last step is to get the accept count, as I had shown here. last step is to get the accept count. This is the count for each of the table, and then insert the value into the compare log tables. And the test result is, again, I have explained that this is the criteria for test result, and then we iterate on to the next value. Likewise, it is going to iterate across all the files that have been loaded into the database. So if we take a look, uh, it is going to iterate across the two files and get the source and the target counts between these two and these two, and then populate the value. So our complete final value is again populated here. So that is it. That is all this tool does. Now I have just not explained one last thing, that is the is data compare. Now the problem here is, as you go on comparing, as multiple users go on using this tool, the compare database will bloat, and because there will be a lot of files of larger sizes being compared, it is going to bloat. So if we clean up or drop a particular table, it is not going to suffice, because the database is going to expand, and it will not shrink. We have to shrink the database. So, and more so, the anchor table or the results table is on the different database, that is the dev database. So actually, once the testing is done, we don't actually need it. After some time, the tables are useless for us. So what the property does is compare db does is actually it drops and recreates. When you set the value to 1, it drops and recreates. So to show you a simple example, I have created a directory 2, and directory 2 contains 3 files each in the source and the targets. So let's try to compare that with the help of dt exec. So the comparison is done. Now if we try to take a look, this is the result. So for feed id 101, we had 3 files, and the comparison result is something like this. Now if we take a look at the object browser and see the tables, the table have been appended. So the size of the database has expanded, first of all, and it is consuming more space. Now let's try to run the same thing, but with the value 1. So what this will do is, we are going to compare right. So this will actually drop your database and recreate it, and then use your source and the target directory. So now if you see, your compare log will have the results of the next run's comparison, yet your database is cleaned up. So if you see, you're just hosting the current run tables and not the erstwhile. So basically you can this is a maintenance mechanism. This is a maintenance mechanism for your server, and you can run it maybe weekly, so that your space is the database space is released onto the server, and the server remains healthy. So that's a quick demo of a tool. Further to this tool can be aligned with a UI, so that the parameters that I have mentioned can be fetched in and populated on the UI, and the backend is that would be an elegant way, but that is out of the scope of current demonstration. So I leave it here, and I hope this is going to add some value and help to you guys. Thank you.